Today, we're diving into something huge, a fundamental shift in how we actually build the future. We're going to look at a totally revolutionary new way of thinking about engineering design, one that's powered by AI and is set to change pretty much everything, from green energy all the way to national defense.
So to really get why this new approach is such a game changer, we first need to understand the sheer scale of the challenge and what's really at stake here.
Let me just start with a question. What do you think is the one critical piece of technology that links the entire hydrogen economy, next-generation aviation, and our most advanced defense systems? I mean, they seem like they're worlds apart, right? But they all share a common vital heart.
And here's the answer. It's the high-efficiency turbocompressor. Now, I know that sounds super technical, but these devices are the true unsung heroes of modern technology. They are these incredible, precision-engineered machines that are designed to compress gases with just extreme efficiency and power.
Their role is absolutely central. For the hydrogen economy, they're the key to storing clean fuel. In aviation, they're literally at the core of advanced jet engines. For defense, they power critical systems. They even drive efficiency in huge industrial processes. So the bottom line is, our ability to move forward in any of these fields really depends on our ability to build better compressors.
But here's the big problem. Designing these components is one of the most complex challenges in modern engineering. It's not just that it's difficult. For a very long time, it's been a slow, incredibly frustrating, and unbelievably expensive process.
The best way to think about the traditional design process is with this analogy. It's like you're trying to find your way through a gigantic, complex labyrinth, but all you have is an old, incomplete paper map. You kind of know where you want to go, but the map is based on old data, it's missing a ton of detail, and every single wrong turn you make costs a huge amount of time and money.
And this slide just lays out the problem perfectly. Over on the left, you've got the old paper map method. It's a slow slog of trial and error, and it often forces you to rely on really expensive software made in other countries. That software is built on old, limited data, which makes it totally inflexible for new challenges, like, say, designing a compressor for hydrogen instead of just plain old air.
So if the old way is a paper map, what engineers desperately needed was a GPS, right? An intelligent guide that could navigate that whole labyrinth for them. And that is exactly what this new project set out to build.
The main goal here was to develop a smart, homegrown software platform made specifically for designing these incredibly complex compressors. The whole idea was to create a tool that could replace those expensive, rigid foreign systems with something that's faster, smarter, and built for our own needs.
And this just brilliantly shows the power of this new way of thinking. This AI-driven software acts like a high-definition GPS. It analyzes millions of potential routes, or in this case, design parameters, and it finds the single most efficient path in seconds. Not months, seconds. And crucially, it does all of this while strictly, and I mean strictly, obeying the fundamental laws of physics. No guesswork. So, you might be wondering, okay, but how does an AI understand physics? That's a great question. It's not magic. It's actually an incredibly clever process that gives the AI this powerful kind of physical intuition. Let's pop the hood and take a look.
It all happens in 4 stages. First, the system runs thousands of virtual tests using what's called computational fluid dynamics. Think of it as a super sophisticated computer simulation of how gases flow to create a massive data set of what works and what doesn't. Second, deep learning models get trained on all that data so they can predict the performance of any new design in milliseconds. Third, and this is the really amazing part, it uses a technique called symbolic regression. Instead of just guessing, it actually looks at the data and discovers the underlying physics equations that govern the whole system. The AI literally learns the rules. And finally, advanced algorithms search through all the possibilities to find that one perfect design that balances everything.
So, okay, we have this elegant AI process that learns physics and finds these optimal solutions. But an algorithm isn't a physical device, right? So what's the actual tangible thing you get at the end of all this?
This is where the whole thing just pays off in a huge way for engineers. This is what bridges that massive gap between a brilliant idea and a real-world machine that you can actually build. Here's the key. The software doesn't just hand you a list of numbers. It automatically generates a complete manufacturing-ready 3D model, a CAD file, of the optimized compressor. Something that used to take a team of engineers weeks, or even months, can now be done in seconds. And it is built for the real world. The interface is super intuitive. The 3D module is all automated, and it exports files that work perfectly with the software engineers are already using every day. This just drastically speeds up the entire research and development cycle, turning what was a slow, painstaking process into one that's rapid and creative.
When you put all of this together, it becomes really clear that we're looking at more than just a new piece of software. This really represents the beginning of a whole new chapter in engineering itself.
And this isn't just some concept. The results are proven. This number here, an R-squared value of 0.916, okay, don't worry about the term. Just think of R squared as a score from 0 to 1 on how well the AI's predictions match real-world results. A score of 1.0 would be a perfect prediction. So yeah, 0.916 is incredibly close. It proves the system is not only fast, it's also highly reliable.
The impact here is just massive. It reduces a nation's dependency on that expensive foreign software, which boosts its own industry. It makes companies way more competitive in strategic sectors like aviation and clean energy. And maybe most important of all, it strengthens technological independence, creating a powerful new tool for innovation right here at home.
And this really brings us to our final thought. This technology is already being used to reinvent a component that is central to some of our most advanced machines. It's changing the way we think about design itself. So the question we're all left with is this: if AI can redesign the heart of a jet engine today, what fundamental human challenge is it going to solve for us tomorrow?